And in this example, we're going to use geometry to help us find an area. We're not going to find the whole area, but we're just going to use it to help. And we're going to go back to this example. You guys remember this example? Yeah. So we've done it a few different ways. We've done it by partitioning and taking the upper function minus the lower function on both those partitions. We've done it by finding the area of two different regions and subtracting using integrals. We've done it by changing the variable to y. And now we're going to do it by using geometry to help. So to use geometry to help, there's a part of this region, and actually it's not even part of the region, but it's outside of the region. But there's a part of this picture here that I can use a geometric formula to find the area of. What part would that be? If we look at the x minus 2 part from 2 to 4, we can find this area using a geometric formula. That's just a what? It's a triangle. It has a base of 2, has a height of 2, and so the area of this is going to be 2. I'm going to do this. I'm going to shade it in here. So that area is 2 times 2 divided by 2, which is going to be 2. So the area of that red region is 2. So then how could I use that to find the area of this region, the one that I'm looking for here? Subtract what from what? Not hearing anything. How about this? How about we find the area of this whole thing and then subtract what? The triangle, right? So how do we find the area of that whole thing? Integrate from 0 to 4 of the square root of x with respect to x. That's the area of that whole thing. And then we subtract 2, the area of that triangle. So this area here, rather than using an integral to evaluate that, we just use a geometry formula. And then we know how to evaluate this. That's going to be 2/3 x to the 3/2 evaluated from 0 to 4. And then don't forget our minus 2. And I'm going to save you the time of the work here, but you end up getting 10/3 again. So that's the fourth different way we've done it, and every time we've gotten the same answer. Honestly, I can't really say any one of these ways is always going to be the best. Sometimes you'll want to just partition it, set up two integrals, and add the areas together. Sometimes it is a lot easier to change it with respect to y. Sometimes the easiest thing is just a geometry formula, and it just depends on the problem. So if you get good at recognizing what integrals are easy to evaluate and which ones aren't, then you're on the right track to figuring out which method is going to be the easiest to evaluate. Any questions about this before we move on?